Welcome to the Real Python Podcast. This is episode 132. How do you create a computer opponent for a simple game within Python? Would you also like to learn how to adapt the game to run in a web browser or graphical user interface? This week on the show, Christopher Trudeau is here, bringing another batch of PyCoders Weekly articles and projects. Christopher shares a recent Real Python step-by-step project for creating a Tic-Tac-Toe game engine. He talks about how to build the game engine and adapt it for different front ends. The tutorial also shows how to implement an unbeatable computer player using the minimax algorithm. We discuss an article about how to avoid repeating yourself when creating decorators with multiple parameters. We talk about how you can stop copying and pasting code several times by assigning the decorator to a new variable. We share several other articles and projects from the Python community, including a news roundup, a deep dive into Python's doctest, several Python command line tricks, type annotations via automated refactoring, a new way to draw boxes in the terminal, a collection of projects for beginners with source code, a minimalist PDF creation library, and a tool for sensible logging within Python. This episode is sponsored by InfluxDB. InfluxDB time series platform is built to handle the massive volumes of time series data produced by sensors, apps, and systems. Are you building real-time applications? Check it out at influxdata.com. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Christopher, welcome back.
Good to be here again.
We have a couple little news tidbits here, so I thought maybe we could hit them first. You want to start with them?
Sure, right off the top. So the first one is that, in case you were tired of all that Python 3.11 news, we're on to Python 3.12 already.
Yay!
Alpha 1 is out. So if you're wanting to play with some of the new stuff, it's there. And the other one is just a quick reminder that the call for proposals for PyCon US 2023 is still open and will be for a week or two. So if you're interested at speaking there, then you should check that out.
Yeah, definitely. There's some internal conversations going on inside Real Python of people thinking about how they want to do different talks. And Garan has done several over the years. He did a lightning talk, I think, last time. And are you planning on coming?
Probably not.
Okay. We'll figure out a way to drag you out of there.
I'll stay bunkered down in my Canadian fortress of solitude for a little longer.
Sure, that's fine. All right. Well, diving into articles and topics this week, I'm going to start with a Real Python one, and it's from our favorite Leodan Esposo Ramos. It's a recent article he did. Basically a tutorial diving really deep, as he likes to do, into Python's doctest. And the subtitle is Document and Test Your Code at Once. And so the idea here, as we've talked about doctest for a few episodes, I think episode 118, we talked about an article from Martin Broyce, which was getting into MK docs and generating documentation using doc strings and how that can be used in that kind of nice twofold factor, and MK docs kind of just finding that information and building out your documentation from it, which is really nice. This covers a whole bunch of stuff. It covers the fundamentals of writing doc tests in your code's documentation and putting them inside the doc strings, and then understanding how the doc tests actually work internally, and then exploring some of the limitations, like where it kind of falls down. And I thought you had some input we were going to kind of talk a little bit about. You're like, well, I don't know if I would use it for everything. And this definitely covers some of that. And then there's also a security implication that you might not think of right away, especially if you're looking at other people's code or code that you're not familiar with, and how maybe running the doc test might not be as secure. And then the last thing he gets into is a couple real deep dive things, strategies that I was not familiar with inside of playing inside there. But it starts out, and he gives links to PEP 257, which talks about docstring conventions, how the most common way that I've seen doctest used is to write it in that triple quoted docstring area. And what's interesting about them, if you need a little refresher on doctests, is that you write them in this sort of special format that looks like you're running commands from the terminal. And so you have that triple greater than symbol. And as you're going through that, as you see that prompt, like you would in a REPL, you type out your test. So maybe it's something like adding. And so you have, call the function add parentheses 4, 2, and then right below that, you'd have the line where the result was 6. And in that, this is showing not only somebody who's reading your documentation what should happen, but you can then run a command from the command line to run the doc test across this. And that would be like, Python-m. The command is doctest, no spaces, and then the name of the file, and it goes through and runs it. And then there's a way to run it with a -v flag that would give you a verbose output that actually tells you, normally if you just run it and nothing happens, yay, nothing failed. And so you're all good. But if you want a more verbose thing where it actually shows you, it'll say like trying, and it'll show each line, trying, expecting, and then okay. And so it goes through all that, showing you the output. He talks about what sort of matches are expected and actual test output, some other kind of corner cases that you might run into there. He talks about how you could use it for catching exceptions and how you would write that and how that looks a little different inside there. And then as you go to build something a little more elaborate, you kind of start to hit the limitations of what you can do in there. But I think one of my favorite things that I learned about by reading this is that you can create the doc tests as standalone files if you want also, which might be handy depending on how you're deploying the code, or if you feel like the doc tests are potentially cluttering up the documentation, you can put the doc test inside of just a text file or a markdown file. So you can run them independently of that. He shows that. As he goes along, he talks about a few more sort of security limitations and things you might run into, because it is running eval, which you've probably heard us even talk about, that you may not want to run eval directly on code that you're not that familiar with, because it's just, literally running inside your machine. So it's a risky method that could allow execution of, just arbitrary code. So something to keep in mind. And then he covers a little bit about test-driven development and how you could do that with doctest. And then really dives into like, okay, well, the next level is PyTest or unit test, where the differences are there and what you would get into diving into the next level of that sort of stuff. So he covers how you can use unit test and PyTest to run your existing doc tests, and how to kind of integrate it. But one of the limitations that doctest has is it doesn't have the ability to use something like fixtures or setup and teardown mechanisms. It really is very specific about sort of exact matching for many of the things that you would be checking for. So it doesn't have a lot of flexibility, if you will, because it's really just sort of text strings that you're sort of checking about it. And a funny thing that he mentioned, we had that article that was covering ellipsis recently. There's actually a way to use an ellipsis and using this technique inside of doctest where you can sort of add like these little directives to say, hey, in this particular case, here's some potential flexibility I might be looking for. And you could say, maybe it's looking for an object ID number or a memory location or something like that. You could actually have like a 0x ... And so that kind of like a wildcard allowing other options there. But again, this article really dives deep into this stuff. I think you may, if you're new to the subject, the first half of it really is going to get you going and working with it. And then as Leonidas likes to do, he goes much deeper into all the corner cases and lots of other kinds of areas to kind of give you much more background and understanding on. I'm a fan, especially for smaller projects. I think it's a good way to set up tests and kind of get going on it. And I was going to ask you, you had said to me that you're not a huge fan of it. I'm not guessing it's just depending on the types of projects. Something like Django, where you're going to maybe need fixtures or you need to kind of talk to databases. This really isn't going to work kind of the way that you want. Is that kind of your feelings?
So let's start from having some tests is better than not having some tests.
Okay. Yeah.
So if you're in a place where this gets you to write some tests quickly, go for it. What I find is it doesn't take long before you start running into those edge conditions. And so I wasn't aware of the addition of that ellipsis thing. But even with it, you're not fully testing it then. You're sort of saying, output kind of looks like this. Right. And so I find it doesn't take much until you end up having to go into a unit test.
Yeah.
And once you're there, there's little advantage to keeping both. You're already there. And I don't find that the unit tests are that much more complicated. The doc tests are definitely easier to read. So for someone who's new to the language, or you don't want to troll through a whole bunch of unit tests, it's very obvious what you want. And I don't remember how we got on the topic, but months and months back, we talked about, I have used it in the outside file format before.
Oh, okay.
So when we build courses, I've got a little engine that shows the REPL on the screen, and I'm not actually showing the REPL in real time. I'm showing a little recorded thing. And the file that I keep that in just looks like a REPL session. And so I am able to use doctest on that to make sure that it actually operates correctly. So I haven't screwed something up when I copy and paste it into it. So one of my open source libraries is something called Torquemada, and it does a few things. And one of the things it does, in addition to like Black and a few others, is it goes through and reads those REPL files and runs them through doctest.
Okay.
So I've used it, but like I said, I tend to... I have found most of the times that I've used it, the constraints, you start hitting the constraints too quickly.
Okay. Start bumping your head against it.
Yeah.
I just really like that tie-in with the documentation part of it. Again, it depends on the complexity of what you're trying to show off and so forth. But that idea of writing out and having it kind of create the markdown files and stuff like that kind of reinvigorated my desire to like, well, this might be a really great way to go. But again, you're going to eventually maybe hit a point where you're like, okay, well, it's not going to be able to like kind of get you much past that as you start to get into much more elaborate types of setups and things where unit test and PyTest and so forth kind of make more sense.
Yeah, and I kind of wonder whether there's some clever way of doing something to get around some of this stuff, like whether somebody could write a library that you always use a function, and because the function is doing the checking or whatever, from the doc test point of view, it's correct. Some way of sort of mixing in the idea of an assert from the unit test or something like that. That there might be a way. If you could get around things, the one I always run into, and it's a pain with tests, is things like dates, right? So
okay.
And you need to mock something up, or you need to explicitly say, okay, the date is today, or you're operating with this date. And if you make any call that goes and checks what date it is, then in doctest, you're stuffed, because it'll go off and figure out what date it is, and it's no longer matching what's in the file, right?
Yeah, doesn't help for variability like that.
It just doesn't like that kind of stuff, right? So if there were some tools out there that could handle some of those cases, I'd be all for it, because it definitely is easier to read. Because like I said, it's just like looking at a REPL session, and that's kind of where we all start, right? We're used to experimenting in the REPL, so yeah, it just needs that extra thing before it convinces me.
That's fine. So you had your first one was going to be a real Python one also, right?
It is, yeah. So this is a Bartosz Zasinski article, and it's called Build a Tic-Tac-Toe Game Engine with an AI Player in Python. So I've heard tales of a chicken in New York City that plays tic-tac-toe. So in case you don't have one of those chickens, you can write some code to be your own electronic chicken.
Right.
And that sounds like a 70s funk band. Now coming to the stage, C. Bailey and the Electronic Chickens. Where was I? Oh yeah, Python, tic-tac-toe. Crap. Anyways, so the article uses tic-tac-toe to teach a couple of concepts. One, it uses a sort of a library-based structure so that your front end and the game engine are separated. And this kind of architecture allows you to build different front ends, say one for the web or one for TK Inter or something like that. and it keeps the game engine separate. And so it's neat that he sort of walks you through the design concept and why you might do that as beyond just the, hey, tic-tac-toe.
Right.
And then second, it does a little bit of introductory AI algorithm stuff, showing you something called min-max evaluation. This is a way to get your computer to look into all possible futures within the context of tic-tac-toe and choose
Right.
the move that will have the best outcome for it. And this is how a lot of computer game AIs work. So this is an interesting little intro to that. So to get going, the article outlines project structure, explains the design decisions behind it. The structure separates the front and back ends, like I said. And within the engine, it separates the game structure from the logic processing. So it, and it includes the typical Project TOML and Virtual M stuff as well. So if you're new to these kinds of mid-sized projects, rather than, say, writing your first, just a simple script, it walks you through all that stuff. And although Tic-Tac-Toe is a relatively simple game, by the time you're done, you'll have touched a lot of modules. You'll need some familiarity with object-oriented coding, data classes, regexes, and recursion. And so he helpfully provides a bunch of links to other articles in case you need to brush up on any of those topics. With the base structure in place, you start by writing code that describes the state of a game. And this includes an enum containing the X and O's, that's knots for British listeners, along with encoding the positions in the board. There's a little bit of regex use here to make sure that the board data only contains those X's and O's, as well as some empty spaces. And then once you've got a board, the next step is to define a move. So you're going to need this in order to have the AI look into all the possible future moves, as well as determine if a player is allowed to do an action. So you have to codify all of this. A game state object tracks all the possible states of the game, not started, ongoing, and then the 3 possible finishing states, tie, X wins, O wins. And the game state code includes data about those winning boards and what they look like. And then the same idea is applied to valid and invalid board states. So you shouldn't have a board with, say, 9 X's, for example. The article walks you through how to take this logic and refactor it out into a place where it's more reusable. So because it's step by step, you're starting with like a little thing and you practice a bit and you get it and you test it. And then maybe this should live somewhere else. So it's very much like at least how I code. I shouldn't speak for everybody, but this is a common practice, right? You rethink things as you go along. Now that you know whether a state is valid, the next step is to figure out what are the allowed next steps in the game. So given any in-progress board state, what are the legal next steps? And being able to answer this is the first thing you need for that future prediction thing that I keep making references to. So once you've got the data models in place, you start putting all this together through a rough scaffold for the game. And that includes things like different renderers so that you can have like a command line versus a GUI renderer. And now we get to the interesting stuff, which is actually playing. So you build out your first little renderer, and that's based on ANSI escape sequences that clear the screen and control where things are printed in the terminal. So you got your little XO board going on. And then it adds a bit of randomness and allows the computer to play itself. And the computer at this point isn't playing smartly, it's just randomly making valid moves. And then the last step the article dives into is the AI. So, greetings, Professor Falcon, shall we play a game? Esoteric 80s movie reference that probably only you and I will get. The min-max algorithm is a common AI tool for computer games. So how this works is it uses a tree representation of subsequent game states. So you start with the current state and then imagine all the possible next states. And those are put as leaves in the tree underneath that current state. Each of those leaves then does the same thing, and you keep going and building this tree. And eventually you're going to get to some leaves that you can't get past because they're end states. And then you find all of those and you mark those with ones, minus ones, and zeros for winning, losing, and tying. And then you walk those backwards through the tree, annotating each of the branches to score the outcomes. So this allows you at the state you're in to say, oh, I should take this branch or I shouldn't take this branch, maximizing the chance of winning and minimizing the chance of your opponent doing so. So basic like things like chess engines and things like that use this algorithm to play against computer users. The difference is tic-tac-toe, the board space is so small that the computer can see all the possible states. Something like chess or Go, the number of positions is huge, and so they can't see completely into the future, and so then they start adding other algorithms to try and make guesswork. But for tic-tac-toe, Python can just basically see the entire future, which means you really can't beat the chicken. I mean, computer. And the article caps it off with writing a nice little wrapper that takes command line arguments to determine whether you're playing against another person or the random computer or the min-max based one. And like I said, there's no option for chickens, but whatever. That's so deep article, lots of nifty little stuff here, far more information than you would ever expect out of tic-tac-toe.
Yeah, it there's actually, I don't know, the percentage of article that's covering, the setup and getting it to be graphically created and so forth and making a random one and then adding the AI is actually on the smaller side of the article as far as like diving into it. And maybe that's partly because of the fact that it's, like you said, there's not as many potential choices for it to go through to kind of try everything out, but it's neat. He really dove deep into this. That's cool.
Well, and as much as this kind of, min-max is a strategy that gets labeled as AI, it's one of those things, though, you can code it in very few lines. Like it really is, you're just walking a tree and looking for some conditions. So in a game like tic-tac-toe, where there aren't a lot of conditions, the AI here doesn't really have to be particularly smart. But I also, I distinctly remember one of my profs who was in the AI space saying that eventually all algorithms that solve a problem get removed from the AI space. So this was considered like cutting edge stuff when they came up with it in the 80s or 90s. And now it's like, oh yeah, we'll just apply it. No problem. and now it's like, I'm not sure that even counts as AI anymore. Right. So
yeah.
When you're talking to your computer and it's answering back to you, a simple branch mechanism seems antiquated.
Yeah. I mean, this is like the types of algorithms that would have been in early computer games as far as like, just creating movement and, simple enemies.
And they're still used. Yeah, they're still used.
Awesome. Time series data runs almost every technology. But building real-time apps in legacy databases can be a nightmare to manage. At InfluxData, creator of the time series data platform InfluxDB, they built their time series platform with tools so developers don't have to make wholesale changes to their product or application just to use InfluxDB. InfluxDB is optimized for developer productivity, so developers can build IoT, analytics, and cloud applications quickly and at scale. Check it out and start for free today at influxdata.com. That's influxdata.com. That takes us into my next one, which this one's a little shorter. It's diving into a set of command line tools that you might not be familiar with that are actually running Python, but just straight from the command line and not requiring you to create a whole script and so forth. It's a Medium article. It's by Martin Hines, who we've heard from a few times before. He starts out the article, the title of it is Python CLI tricks, command line interface tricks, that don't require any code whatsoever. I'll reference a few of these things. The first one he gets into is time it, which I think we've talked about, on a handful of different times, getting into sort of a version of profiling your code and benchmarking how it is running. Time it is a very popular tool for that. The command line would look like basically Python-m time it, and then you'd run your code, and then you can set a whole bunch of different flags to choose like how many loops you want it to go, and which sometimes you need to be careful of because it might just keep going on forever. And there are examples where it will automatically run a certain number of loops to just get an idea of like how many, everything from microseconds that the loop takes to run and so forth. But it's a nice tool. Again, just kind of get going with it. The next one he talks about is PyPerf, which is a little more advanced in some of the stuff that it can do. One thing that I haven't run it very often, but one of the things that it can do is a histogram, which I thought was kind of interesting. and can kind of show you the results in sort of bins to indicate different performance characteristics as it was running through. So that might be a handier one depending on the type of code you're trying to run through it. And then he talks about C profile, which gets into, a little more elaborate kind of stuff as far as actually more truly profiling your code and looking at the individual modules that are running as it goes. He gives some links for diving deeper into Python profiling. And we had a whole article recently, or a whole podcast recently about memory profilers and some of those other kinds of tools. And there's definitely those types of routes where you might run into from there. The next one that he covers, actually, we had talked about in episode 97 with Adam Johnson, where he was helping kind of improve your Django Python developer experience. And he had mentioned the ability that you can run a server inside of Python. And the way that we were talking about running it was that you can set up documentation and run a server pointed at this folder, and then you're running potentially all the documentation, like maybe locally on your computer, and being able to access it the way that it would normally be able to get to it online. And it's just, again, Python-m, in this case, http-.server, and then what port you want it to run on, and then, what kind of directory that you're pointing it to. Very handy tool.
Yeah, I use this one a lot. My corporate website is a static generated site based on a Django project called Distill that takes a Django site and turns it into a static site. And when I'm testing to make a change, the easiest thing to do is just point this web server at the directory and then use it in the browser. It's fantastic.
Yeah. Yeah. Again, just, the idea that you can just kind of stand something up and then kind of poke at it, and that it's one of those batteries included. These are ones that we hope we keep. So have you used this next one, the FTP?
No.
Thing? I had never been familiar with it.
I haven't.
FTP.
I haven't touched FTP in quite some time.
Yeah. Well, I use it occasionally, again, talking about simple websites or static websites that occasionally have to help with other family members that have really simple sites that they want me to update and so forth. And so FTP is still my simple way to get in and out of updating things. But I thought it was interesting that you can set up an FTP server really quickly and then access it. And I didn't try it out, but that one sounds kind of interesting. He also has a reference to the library Twisted to do something like that. Twisted FTP is another one. Then he gets into debugging with PDB, which again, from the command line might be a handy way to kind of approach it. The one that I have seen you use that I thought was very interesting is this one where you can do parsing of JSON. Again, something built into the Python standard library is the JSON module. And so you can use this JSON.tool. JSON in its raw form is rather ugly and hard to parse. And so there's a way to have it printed out. And I had seen you do this in a handful of the video tutorials where you were discussing, most recently, the Ninja API setup that you can do, Django Ninja.
Yeah, I think I used it in the DRF course as well.
Yeah.
Any time where you're getting, JSON back from something through, say, curl, this is a quick and easy way to do a nice little pretty print on it.
Yeah, so it's just, again, Python-m and then whatever commands you're pulling in JSON.tool to look at the output there can be able to be handy. And the last two he covers are compressing and packaging. He covers doing gzip, which would be like individual files that you want to zip up, or the more advanced one is zip app. And then he actually calls out a real Python article in there from Leodonis. It's a neat tool where you can actually build executable zipped up applications with zip app. And so instead of having to provide somebody like, this entire directory structure and so forth, you can provide them just the single file, and then it can actually, be a standalone Python app in a way, which is pretty cool. So I'll include the link to that article also. And then I think the last one is you have to have this set up in your terminal, but you could launch a web browser. So you could have it call out and have it, actually start up Chrome or what have you. I feel like this is a whole path. Like if you're very, very terminal focused and do a lot of work inside, there's a lot of great tools that you just might not be aware of that are low hanging fruit for you to get a little more handy stuff happening inside your terminal.
Yeah, the debug one that you mentioned, I'd only learned about this one recently from one of Gararn's articles, actually. And it's the -I parameter to Python, and it's not specifically for debugging. What it does is it runs your script and then kicks you into a REPL in context of the script. And in the article, he goes and then imports PDB in order to start doing things in the debugger. But you can do other things with it as well. So if you're just trying to, like, say you've got some functions in your script and you want to play with them interactively, if you do -I and the script only has the functions, because there's no _main, it won't do anything. It just loads the functions into the context, and then you have it inside of your REPL space. And then in the REPL, you can call the function and play with the function.
Yeah.
So it's a neat little, play with your code experiment kind of thing without even needing the PDB side.
Yeah. I'm sorry I didn't call that one out, but that definitely is one of the handier things. He had talked to me about it a long time ago. He was using it with other REPL tools to kind of do that sort of interactivity stuff before.
Yeah.
Yeah. Cool. So what's your next one?
So this is something called Type Annotation via Automated Refactoring by Jimmy Lai. And if you're not a first-time listener, you may recall I'm not a huge fan of type annotations. So you might be wondering, why am I talking about this? So although the article is nominally about type annotations, it's really not about type annotations. Jimmy works at Carta, which is a company with over 2 million lines of Python code. And they decided they wanted to start using type annotations. This article talks about the automated tools they built to help them do this. So the fact that they're trying to add the type annotations is almost secondary. How they go about doing it and the process they have and all the things they have to think about is quite deeply covered in the article. They started out by investigating their current state. So they have more than 100 Python repos at the company, and so they picked one of their more active ones. It has 200 people working on it at any given time, and it turned out that they only had about 14% of the 120,000 functions inside of it were fully typed. And they wanted to do something about this. They figured if they were able to add about 30 annotations per day, that would be 10 years worth of work, assuming no one else added any code in the meantime. So this was why they were going down the automation path. They had done a similar process in the past, trying to make their code compliant with the black code formats. And one of the things that they learned through that was if the automation tools opened up too many pull requests that were too large, chaos ensued. So they found that through that project that PRs of 1 to 200 lines of code were sort of a good range. And they also figured out how to use some of the metadata from GitHub to try to make the PR impact only a single team at a time if possible. And all of this, again, was just trying to reduce that whole ensuing chaos thing.
It could warn that group, here comes the change.
Exactly. That's exactly right. So so once they had a commit strategy in place, they identified some low-hanging fruit, and they came up with 3 things. One was dunder init statements should return none. Makes sense. Built-in functions, so things like dunder string and dunder hash have well-known return types. So dunder string returns a string, dunder hash returns an int, etc. And then some of their functions doing sort of a basic code scanning thing have obvious return types. So if all the functions always returning true or false, then, add the mapping to bool. Jimmy goes into great detail about how they used a package called GitPython to manage the commits and their pipeline. And they even included notifying the code owners via Slack that, hey, change, like you said, changes are coming. And as a person has to actually accept the PR, they also did a little gamification thing to make sure that the coders were actually taking in the requested changes that were coming from the tool. So in a little over a year, they went from 14% compliance to almost 70% compliance, and they're hoping to hit 100% by the end of 2022. So this is an ongoing thing. So whether or not you're a MyPy guy or gal, the article does a great job of sort of walking you through what it's like to make automated changes to a large code base. And so I found there was a lot to learn here, even independent of whether or not you want to do the typing thing. And when you're dealing with 2 million lines of code, this is exactly where you should be doing typing. You want this kind of rigidity when you've got a larger code base because you want the extra checks. So
yeah, and getting all those teams to agree on what's coming in and out of the code. Yeah.
Yep.
Awesome. So we had a couple short ones that we both wanted to mention. And mine is from Will McGugan of Rich and Textual fame. He was a guest on episode 80. We talked a lot about working and creating these TUIs. And his article is just a short and sweet one. It was a new question mark way of drawing boxes in the terminal. And he was noting that as he's drawing these, pretty common box shapes, that he's using ASCII or other additional types of characters, and often the ones that have lines, and then you can make these shapes to create a box. The lines were like in the middle of a square. And so if that square is shaded, it means that there's going to be shading on the top, then a line, and then on the bottom, or whatever is on the outside. And he's like, man, this is kind of ugly that there's always going to be this background color kind of outside of the lines. And so he started to think about it a little bit more and said, well, there are boxes that have vertical and horizontal lines that are on the edge. So like you could think of like a top box that has a line that's just at the top, and then the color or whatever the background is below it. And the same with the bottom would be something above, and then just a line on the bottom, and then ones on the left and the right sides. And he thought to himself, well, wait, maybe I can just flip this thing. And so by flipping the box that normally would be considered a top line and making it be one that has a line just on the bottom, it allows him to create these box shapes that don't have that weird kind of outer shading. And he jokingly called them McGugan boxes, which I thought was pretty funny. So he's looking at I guess this must have just came out then. The next release, the Textual, came out on October 24th, if everything went smoothly there. And anyway, so he's looking at some new ways to create these boxes and kind of remove some of the additional clutter and so forth. So if you are, we've talked about in the release of Python 3.11, how they were doing a little more of this, I was calling it ASCII art, but these lines and boxes and underlining and so forth. So this is a common technique if you're doing terminal output. And here's another way that you could maybe make it look a little more attractive.
Yeah, they're sticking to pure ASCII art, though. They're using dashes and pluses. It looks very 1980s. So.
Yeah, and underscores. But hey, you could. Yeah. So what's your little shorty?
Yeah, so this is a post called Decorator Shortcuts from Ned Batchelder. It's a simple little thing that kind of made me go, of course you can do that. Why didn't I know this? And what the post talks about is Ned sort of reminds us that decorators are just functions, which means you can call them. And that seems obvious, but why would you want to do this outside of the context? Well, it turns out that this can save you some typing, and it can enable reuse in certain cases. So a common case here is, let's say you're using PyTest, which uses decorators to manage test functions. Some of these decorators have a large number of arguments associated with them. For example, if you set a test to fail automatically if a certain version of Python is used, doing so requires a test condition as well as an error message. If you wanted to wrap that decorator around many tests, you'd be typing that out a lot or copying and pasting it. And if you want to go in and change the Python version, now you've got to go and change it all, right? So you're doing this repeat yourself thing. So this little trick is to get around that. So instead of doing the copy and paste thing, you call the decorator as if it's a normal function with all those arguments and store the result in a variable. So in that example I just gave, you might call that variable conditional Python version. And then you use this variable as the decorator. So my test would now have at conditional Python version over the top of a function instead of at pytest.mark.xfail parentheses and then all those parameters. So like I said, it's not something that I'd ever thought to do, but now that I've seen it, I've sort of like, oh, of course. And like most brilliant stuff, that's always great when you see this kind of thing. So it's a neat little, another tool for the tool bag, really, is what it comes down to.
Yeah, it's kind of wild, that it goes back to the idea of everything being an object, and the idea that you can, create, it's not quite a factory, but, in a way you're creating a an object that is this other function, and then you can use that as a decorator. So
yeah, there's decorators and generators and async await are all these like it's executing but it's not executing sort of magic.
Yeah.
And this leans right into it because you're not really calling the thing that's being called. You can wrap it and go, right? So it works.
Yeah. This week, I want to shine a spotlight on another Real Python video course. It's about a topic we touch on this week, and new students to Python can often find a bit confusing. It's titled Python Decorators 101. The course is based on a Real Python guide by previous guest on the podcast, Ger-Arne Jelle. It's a course created by yours truly, and I take you through how functions are first-class objects in Python, how to return a function from a function, how to create simple decorators, creating some syntactic sugar when using decorators, how to decorate functions with arguments, and you'll practice creating several real-world examples, including code for timing your functions, debugging code, slowing code down, and a plugin registering system. I think it's a worthy investment of your time to learn how to use decorators in Python, and to recognize how decorators are being used in all the code you encounter along your Python journey. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. We decided to do something kind of different this week about our discussion topic. We found this article from Aman Karwal. It's actually from a little while ago, but I guess sort of bubbled up. It's 190 Python projects with source code. For each of the projects, if you were to click on one, it goes to a small web page that has a description of what you're going to create, the Python code, the output, and then like a whole comment section and so forth and beyond it. So it's a very elaborate kind of setup that Aman has created here. And I think it's actually pretty genius as far as SEO and getting attention and so forth. But a lot of the projects, I think he mentions them as like Python projects for beginner as one of the dividing lines. And then the other one is advanced Python projects. I almost think of like 3 or 4 different ways you could kind of approach this article as a resource for like a beginner. It could be one of these things where, okay, I want to practice my Python skills. And you could see something like this as number 7, count number of words in a column, or print emojis using Python, or correct spellings, or find a missing number, or some of these games and stuff like that. And you could try to create your own unique version of that and then compare your answer.
Yeah, it's kind of like having the answers in the back of the textbook, right? Like you read the sentence, you go, I'm going to go try this, and then I go see, okay, how did the teacher do it? Yeah.
Right. Yeah. And then I thought of it as maybe like you could look at what Aman created and maybe think of, well, I could improve on this, or I could think of another way to do this. So as like kind of a refactoring type of thing, because there are some examples where I'm like, well, I could see some improvements or some other maybe ways that you could think of as you kind of learn more about the library and you go, there might be other ways to do this. And then the other most fascinating thing about it as I went through them is that often the solution was use this third-party library.
Yeah.
And I was like, oh, well, I didn't even know that was available. So like there's one that's removing, was it cuss words?
Yep.
And
better profanity.
Yeah, there's a library that's just pip install better_profanity. And it pretty much does the work for you. And you might not have known that was available. And so this is kind of a neat exploration of some of these third-party tools that are out there. And so I wanted to, kind of discuss some of these. We're not going to go through all 190, but there were a handful that were kind of interesting as a way for you to kind of get into them. And then that might be a whole side journey into those libraries and seeing what's made of them, and kind of digging into their code and, well, how did they solve that? It's just as simple as, installing it and using it. I'm not saying that you need to rewrite the wheel each time, but, if you're going to use this as an educational tool, that might be one.
Yeah. And because he uses the third-party libraries for a lot of it, very few of these are more than like a dozen lines of code. So that
Right.
they're all. It's not like you're deep diving into go read 1,000 lines of code and try to understand how it is. They're all like little snacky
Right.
bits of there's recipes for doing things, right? So similar to the better profanity one, one of the ones I liked that I'm going to file away is lang detect.
Huh.
And it you feed it some text and it spits back its best guess as to what language it's in. So spoken language, not programming language. So
right. Yeah.
And there was another one which I thought again was kind of cute and cool, which is Python emoji.
Yeah, that one too I thought was cool.
And it uses the name format that's very common in tools like Slack, where you can, say ta-da, and it turns it into the little party
right.
thing. And Python emoji essentially does the same thing, right? And I haven't dug into the library yet, but I suspect it's just doing the Unicode lookup name.
Right.
I'm hoping so, because otherwise somebody has spent a lot of their time typing all that stuff in.
Yeah, I thought about this one, the scrape IMDb, and I'm like, oh, whoa, what's that got to be? And IMDb has a library.
Yep.
You literally can pip install IMDb, and then from there you can get specific movies or look at the different fields that are in. It's very much a database, kind of API connection. So, but pretty slick.
Yeah, and the other thing I found too was because a bunch of them are either using standard libraries or popular libraries.
Yeah.
Again, that sort of recipe thing, it was a neat way of sort of, how would I do X? Right. So there's a short one in here about removing stop words, and these are words that you can skip if you're doing semantic processing. So the NLTK library does this with it's a couple lines of code. And but if you were new to this space, or you're sort of trying to Google how would I do this, this is right there. This is exactly how to do it, kind of thing. You mentioned the text columns thing. His approach is to use pandas, and if you say did it and didn't know pandas existed, you go off and you write whatever it is, a couple dozen lines of Python, and then you look at his, and it's like, pip install and then call that function. Okay, that makes it much easier, right? So
right.
It's similar, and there's things like that even within the standard library is found as well, right? So one of the recipes is removing Unicode characters from a string, and that's not even in a module. That's straight off part of the string library, but it's a encode and decode using the right parameters, and you can pull all that stuff and put it back into ASCII land. So again, neat little sort of recipe.
Lots of tricks and tips. Yeah, just kind of hiding in there. Yeah, and and there's a real variety of things like building a music player, GUI, a graphical user interface, and he's using Tkinter in this case, and actually using Pygame, which has a lot of built-in functionality as far as like creating a mixer and other ways to kind of play the music and control that sort of stuff. It's a fun place to kind of like go in and just look through it. There's enough there that it could keep you busy if you're
for sure
trying to be inspired to like try out some new things or there was enough of them that I clicked on like, oh yeah, that would be fun.
Yep.
So
and for our younger listeners, there's some homework cheats in here as well. So
yeah, totally. The interview type questions. Yeah.
Pretty standard computer science type things like queues and Dijkstra's algorithm and FizzBuzz, which is a common interview question, quick sort, some of that kind of stuff. So there's it's quite a mix. It's worth sort of trolling through and seeing what piques your fancy.
Yeah. So that gets us into projects. I'm the resident PDF guy, always talking about PDFs and creating them. It's partly my background of creating stuff for small businesses, I think, and little tools and things like that. I had Mike Driscoll on way back in episode 20, and he had mentioned a particular library that he said, well, it's kind of dead and not really happening. It was this thing it was based on a PHP library called Free PDF. And that one was called PyFPDF. Well, it's been sort of resurrected and updated and modernized. And one of the persons who was involved previously, I believe in this case, is Mariano Reingart. And there's a ton of additional other contributors on this project. So I don't know who gets all the credit there, but it is known as FPDF2. It's a library with low-level primitives to easily generate PDF documents. It has a lot of similarity. In episode 20, we talked about Report Lab. Mike was working on a book about that at the time. And the idea of having cells and flowables, things that can kind of span across multiple rows and pages and tables. And this library does a lot of that stuff too. It has hooks that can tie into letting you to do like subclasses of like headers and footers and stuff like that. Again, this whole thing was developed a long time ago in the PHP language, and then it was sort of a free alternative to these super proprietary C libraries. And I had the creator of Borb on, and he's also another person who created a very powerful library that's got a lot of the similarities here. This one, the tutorials are good. They can kind of get you up and running really quickly if you want to just create something simple. I'll include some links for some additional documentation and then other ports and directions and stuff that people have taken it. But FPDF2, it's a nice project to do, as their subtitle is, Minimalist PDF Creation Library. So what's yours? What's your project this week?
So usually we pull the project stuff out of the PyCoders projects section, which kind of makes sense. This week I didn't actually. This is from a article, but it really is just an article about a library, so same difference. And it's called Simple, Sane, and Sensible Logging in Python, and it's by Pete Feisen. And it's a quick overview of a library called Log2D. And I have a love-hate relationship with Python logging. It's very comprehensive and fairly close to how logging setup works in other languages, which is great. Trying to do something simple always feels painful. And I don't know about you, but I tend to start with print statements and then add logging when I need to industrialize a program because I just don't want to have to think about it. And in fact, I've got logging helpers in a couple of my libraries that are wrappers to common things that I do in Python logging. And I'm going to stop using them because Log2D does it so much better, so someone else can maintain it, right?
Yeah.
So the 2D in Log2D is the idea of configuring multiple loggers, each for its own classification of message. So rather than sticking to just sort of debug and warning and critical, you can classify with things like, say, successes and failure messages and timing or instrumentation, right? And you can do all of this with Python's logging module, but it's painful because you're going to have to do all that configuration. How Log2D works is you create a log object passing in a name, and the log object acts as a singleton. So each time you call it with a new name gets generated. Like say you wanted a success log and a timings log, you'd go capital L log parentheses quotes success, and then again for capital L log parentheses timings, and there you go. You got two logs. And then once you've instantiated those, you can log a message by using dot notation. So capital L dot success and capital L dot timings in the example I just gave. And you can use the sub object to then call the info or warn or debug methods like you would in the regular default Python logging library. And if you're happy with the default format and want to log to standard out, that's all you need to do. And if you want to send it to a file instead, you can just add toFile equals true, or you can specify a path in the constructor. By default, Log2D is set up to do log rotations, so you never have to look up how that works ever again. And that constructor I mentioned also returns an instance, so you can assign that to a variable and use the variable to do the debug call instead if you want to, because you prefer it to look that way in your code. Documentation on this is pretty well done. They've got a nice little cookbook section at the bottom to show you some common things that you might want to do. And I have to remember this one. When I finally get back to doing TUI programming where you can't use print or the ANSI-based debugger with a TUI, so logging is king, this is going to be really helpful. It's going to save me a bunch of stuff. So it's a cool project.
Nice. Well, thanks again, Christopher, bringing all these articles and projects.
Always happy to talk to you.
And don't forget, InfluxDB time series platform is available in the cloud, on premises, or locally. Get started for free today at influxdata.com. I want to thank Christopher Trudeau for coming on the show again this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.